one where we didn't have any vertical lines. We had a horizontal, didn't have any vertical lines where we had a horizontal line. This one here, we've got some vertical lines. Now, it's a little bit different to find the vertical lines. Remember, this here was 60, and this here was 150. If I want to find the intersect of a vertical line, I have to use that function when we do second function trace 1 to get that. So let's get those 4 lines. So we go second function trace. We want to select number 1 for value. We press enter. And down here we're going to say, well, we want x when x equals 60. What are y at that point? So at this first one, when y equals 60, x equals 60, we've got 60 and 140. We go up, just press up. The next one here is, well, this one here is 60 and 170. Okay. We then just type in 150 down the bottom because we're still in that same function. And we press enter, and it takes us straight over to this next one, which is 150 and 170. And then we just want the last one, press down. It's 150 and 50. So we've got our 4 constraints. Let's just write those over here, so we remember them. So it's 60, 170, 150, 170, 60, 140, and 150 and 50. Because that's going to help us work out the optimal solution. So let's go back to our question. And our question here is, how many of each of the 2 products should a company produce to maximize their profits? Okay, so we've got our vertices. Our vertices are here. So we've got 60 and 170. We've got 150 and 170. We have 60 and 140. And we have 150 and 50. Does anyone remember what our objective function was? Our objective function was 65x plus 80y. So this time, you're probably going to need a graphics calculator to do this one. What we're going to be putting here is we're going to say, well, 65 times 60 plus 80 times 170, we get an answer. 65 times 150 plus 80 times 170, we get an answer. 65 times 60 plus 80 times 140, an answer. And then the last one, 65 times 150 plus 80 times 50, and we get our answer. So let's get those answers out so we can put them onto our sheet. So getting this out of here, we've got 65 brackets 60 plus 80 65 brackets 60 plus 80 brackets 170. And we get our answer of 17,500. Now, instead of doing this again, let's go up here and highlight it and say, well, we know we don't have to change those numbers in there on the outside. So it's just going to be, in this case here, we'll do second function, insert 150, don't need that one, so I can delete that. Come across, this one here is 170, so let's do that, press enter. 23,350, again, come back up. The next one here is 60, so we can just say, I don't need that one, let's delete that. Alright, 6. Is it 170? No, this time it's 140. Enter. 15,100. And then the last one, again, over here, 1, 5. Let's insert 0. Bring this across, and is that 140? No, it's not. It's 55. And we get 13,750. So obviously, here is our objective function. So we're now at the point where we've got our objective function. We now need to actually work out, because it's maximised, we have to write it in sentence form. So remember, when we write it in sentence form, we write it using the understanding that X was the boats and Y was the bears. So we write it as, and let's get some nice clear space to write this in. We write it as the maximum profit, because we are dealing with profit, is $23,350 when 150 boats and 170 bears are produced. Okay, so just like the last example, we write down what the maximum of was, how much it was, and we write down X and Y, but this time we have value, we have names for X and Y. In this case, the X of the 100 is boats, and the Y is bears. And that is how we work with those questions. So in your booklet here, if you look down a little bit further,